What are the most common security vulnerabilities that developers have to deal with? Injection attacks. Injection flaws occur when an attacker sends untrusted data to an interpreter as part of a command or query. This can trick the interpreter into executing unintended commands or accessing data without proper authorization. For example, in a SQL injection, an attacker might input this into a login form modifying the SQL query to bypass authentication and log in without a username and password. Cross-site scripting. Cross-site scripting vulnerabilities allow attackers to inject malicious scripts into content from a trusted website. These scripts then execute in the context of the user's browser, enabling the attacker to steal cookies, session tokens, or deface the website. For example, an attacker posts a comment on a blog containing the following script. When another user views the comment, the script executes, displaying the alert box. Broken authentication and session management. This vulnerability occurs when application functions related to authentication and session management are implemented incorrectly, allowing attackers to compromise passwords, keys, or session tokens. For example, a web application fails to invalidate session IDs after a logout. If an attacker gets a hold of those session IDs, they can continue to access the application as the original user. Sensitive data exposure. This involves inadequate protection of sensitive data like financial data, personal information, etc. This can be due to weak encryption, exposure and error messages, or insecure data transfers. For example, a web application transmitting personal data such as credit card numbers in plain text over HTTP. Easily intercepted by eavesdroppers. Security misconfiguration. This broad category includes insecure default configurations, incomplete setups, and open cloud storage. It often leads to unnecessary access to system data or functionality. For example, a web server's admin console is accidentally exposed to the public internet, allowing unauthorized access. Cross-site request forgery. In this attack, a malicious website causes a user's browser to perform an action on another website where the user is authenticated. The target site must trust the user's browser for the attack to succeed. For example, a user logged into a banking site clicks on a malicious link on another site, unwittingly submitting a form that transfers money from their account. Using components with known vulnerabilities. Applications often use libraries and frameworks with known security bugs. Attackers exploit these vulnerabilities when the components are not updated. For example, an application uses an outdated version of a web framework known to have a remote code execution vulnerability, which an attacker exploits. Broken access control. This occurs when users can perform actions they shouldn't be able to do, like accessing other users' data or modifying higher-level privileges. For example, a user changes the URL from this to this and gains access to another user's profile. Insufficient logging and monitoring. Poor logging and monitoring, along with insufficient incident response, allows attackers to further attack systems, maintain persistence, and extract or destroy data. For example, an application does not log failed login attempts, allowing a brute force attack to go unnoticed for an extended period. Insecure deserialization. Insecure deserialization vulnerabilities allow an attacker to execute code, tamper with or delete serialized data, or elevate privileges. For example, an application accepts serialized objects from untrusted sources. An attacker sends a crafted object that, when deserialized, executes arbitrary code on the server. Thank you for watching. Be sure to like and subscribe for more content like this. If you would like to get access to free fundamental concepts about computer science and software engineering, check out my website.